Here we have an example of capacitors that are connected in a configuration that's not strictly series and not strictly parallel, but it's a combination of both. So let's look at what we have. We have C1 and C2. Put these in different colors, see if it kind of helps. C1 and C2 only provide one path for the current or for the charge to flow. So this is series, and then we have the combination of C1, C2 with C3, and these are in parallel. And last but not least, we have the combination with C4, and this turns out to be series. Because the charge that flows through C4 is going to divide, and this parallel combination is going to look like one capacitor. So C4 is in series with this parallel combination. So we need to break the problem up into smaller problems to be able to come up with the total capacitance. So let's look at our total for C, we'll call it 1, 2. And that's just going to be the reciprocal of the sum of the reciprocals. And we know that because it tells us in the problem that all the capacitors have some value C, we can put that in. And that equals 1 over 2C. I'm sorry, 1 over 2 over C. And that just means that my total capacitance is C over 2. So this is the value of this series combination of C1 and C2. Now, let's do C, and we'll call it C123. That's going to be the parallel combination. And that's just going to be equal to C3 plus C12. And that's just C plus C over 2, and that's equal to 3 halves C. And now we can take and find CT, that's our total capacitance, and that's going to be for here, and it's a series, so I'm going to take equal to 1 over C4 plus 1 over C1, 2, 3. That's equal to 1 over C plus the reciprocal of the C1, 2, 3 is going to be 2 over 3C. And we can solve that out and we get 3/5 C. So the total capacitance is going to look like it's 3/5 of each of the individual capacitances in the configuration. So the total capacitance is going to look less than what you would think it would look like, but it's based on how these capacitors are connected in this configuration. Now the next part, we're going to find the charge on each of the capacitors and the voltage potential across each of them.